Okay, good morning. This week we've been working on section 5.3. In chapter 5 is all about normal distributions. And 5.3 is where we start to work backwards, where we're given an area under the normal curve or a probability or a percentage of the population. They want us to work backwards and find the z-score that would be associated with that given area, or in many cases, an actual data value or x value. So let's do a quick review here of how we've been using Google Sheets to find areas under the normal curve first. And to do that, we were using this function called normal distribution. The inputs for normal distribution, if we're using a z-score to find an area, a corresponding area, would be to input z, comma, 0, comma, 1, comma, the word true. The word true tells it to do a cumulative probability, so it's doing a sum of all probabilities. And if we're using an x value, we're just going to transpose. Instead of z, we'll put our x value in, the mean that is given to us or that we've calculated from a data set, standard deviation, and again, the word true, because we do want to do a cumulative distribution. So things to remember here. Normal distribution function in Google Sheets always calculates the area to the left or less than the x or z value that you input into it. So it's always going to give you the area to the left. Sometimes you want the area to the right, so questions ask you to find the probability that something is larger, or the area that's to the right of a z-score. In that case, remember the total area under the normal distribution is 1 or 100%. So we only have to do 1 minus the solution that we get from normal distribution using the same inputs. And sometimes you're asked to find the area between two x or z values, in which case you need to find the normal distribution area for the larger of the x values, and then you're going to have to find the normal distribution area for the smaller of the x values, and you're going to subtract those two. Fix my typo here. And once you do that, you should have the correct answer. So we'll do an example of a question like finding normal curve area first, and then we'll talk about how to find the reverse process that we're learning here in section 5.3. So I have this question here. It's from a different version of the textbook than what we use in class. Heights of men in a survey was conducted. Measure the heights of U.S. men ages 20 to 29. They're normally distributed. It's important that the question says that. With a mean of 69.9 inches and a standard deviation of 3 inches. A study participant is randomly selected. What is the probability that that randomly selected person's height is less than 66 inches? So a less than question is a to the left question. We can come down here very easily. I'm going to type in the inputs, and then we'll actually do the inputs. So we would have normal distribution. Okay, the x value they gave us is 66. The mean that they gave us is 69.9 inches with a standard deviation of 3.0. And you don't need the decimal place. And the word true. That's what our inputs are going to be. I'm going to go ahead and widen that out a little bit so we can see that whole thing. There we go. So we'll just go ahead and do that. Equals normal distribution 66, 69.9, 3, and the word true. And that'll give us our answer right there. So there's around a 10% chance that someone is going to be less than 66 inches in that scenario. Part B, the second question says, find the probability that the height is between 66 and 72 inches. Okay, and in between question, we're going to need to do 2 normal distributions. So we'll need to do normal distribution. We want to use the larger of the 2 values, which was 72. Mean is 69.9. Standard deviation is 3, and the word true. And we're going to then do subtract from that another normal distribution. And we'll put in the original 66 was our x value, 69.9, 3, and the word true. And that is inputs we would need. And I want to make this visible, so all I've got to do here is change my alignment on this one. There we go. I'll drag this over so that all our answers are in the same spot. So we'll go ahead and do that. I'm going to type equals. And that didn't work the way I wanted it to. I'll try it again. I was trying to avoid typing it all out. We can do that. We're going to go here. We're going to go up here and copy this. Down here, equals, and put it in. It still doesn't like what we did because we never closed the parentheses on the end of this one. There we go. So the syntax for this is very simple. So you'll get an error like I just got because it viewed this as a word that didn't make sense or an equation that didn't make sense because I didn't have that second parenthesis there. And this one here is unnecessary. And it still doesn't like it because I missed the letter M. There we go. So be careful. Make sure you type it in correctly. You can see it right here. I missed the letter M there. It doesn't know what a NORD dist is. So there we go. Subtract the two normal distributions, get the correct answer. Last question says, find the probability that the height is more than 72 inches. This is a greater than or a to the right question. So in this case, we're going to have to just do 1 minus normal distribution, 72, comma mean, comma standard deviation, and the word true. Close our parentheses, and that's what we'll need to input here. Equals 1 minus normal distribution, 72 inches, mean of 69.9, standard deviation of 3, and the word true. And there we go. 24% chance that someone is greater than 72 inches in height. So those are how you would answer those 3 questions. This last question here that says, can any of these events be considered unusual? Explain your reasoning. And it's a question of is something a very small probability. An example of a very small probability, let's think back to chapter 2 when we talked about empirical rule. We said anything outside of 2 standard deviations. And between 2 standard deviations is 95% of your data set, which means there's 2.5% of your population that is above 2 standard deviations and 2.5% that are below 2 standard deviations. So none of these values fall into that 2.5% range. So I would not consider any of these unusual. None of these 72 or 66 don't fall outside 2 standard deviations of the mean, which is our usual benchmark for what we consider an unusual data point. So no, none of these would be considered unusual. So that's just a quick review of what we did in section 5.1 and 5.2. These, of course, we're using actual data values. If we were just using z-scores, that wouldn't be any more difficult. We didn't put the z. 0 is the mean. 1 is the standard deviation. Let's take a look at an example now from section 5.3. Let's see, I brought one up here and I don't know where I put it. Oh, you know what? I think I can go ahead and look at this and it'll be a little clearer for us. Here we go. Section 5.3, this is example number 4. And this is finding a specific data value. Scores for the California Peace Officer Standards Training Test are normally distributed with a mean of 50. That's important, so write that down. Mean is 50. Standard deviation is 10. An agency will only hire applicants with scores in the top 10%. What is the lowest score you could earn and still be in the top 10%? So we're going to take a look at this, and 10% is the top 10%, which means there's 90% less than that. And that's important for us because 90% is what we're going to have to use with our Google Sheet function because it is only going to calculate areas to the left. So I'm going to come back here and we're going to put in what we're looking for here. It's normal inverse is the function we're going to use here. We're going to put in the area they want, the area to the left, the mean, and the standard deviation, and it's going to give us the x value output. So we'll type it right here, normal inverse. You don't have to capitalize the I, that's okay. All right, in this case, our mean was 50. Incorrect, we need to put our area in first. Now, they said top 10%, which means there's 90% left. Put it in as a decimal, 0.9. Mean of 50, standard deviation was 10. Okay, let's stretch that a little bit so it fits okay. So that's what our input is going to be. Now we're just going to add the equal sign so that it works. It knows it's an equation. Normal inverse, and you'll see it pops up here. 0.9 for our area, 50 for our standard deviation, or for our mean, 10 for our standard deviation. And it tells us the lowest score you could achieve is 62.815. And we'll take a look here. They say approximately 62.8. This was a case where they had already given you the z-score. We're not going to see a whole lot of problems like that. We're going to see problems like example 4, where we're going to have to calculate the x value directly from the probability or the area. We'll look at try it yourself 4. What is the longest braking distance a Nissan Altima can have and still be in the bottom 1%? Bottom 1%. So, same question. Bottom 1% would mean we're actually going to use 1. I'll put it in here. NormInv. 0.01 if we're going to be in the bottom 1%. Our mean for that question was 129 feet, 5.18. So I'll put those in. 129 feet for the mean, 5.18 for the standard deviation. And we'll go ahead and put it in equals norm inv 0.01, 129, 5.18. It's going to tell us 116.9 is going to put us in the bottom 1%. After that, it's pretty straightforward. Just always keep in mind when you read questions, am I looking for the bottom 1%? Am I looking for the top 1%? And remember that the area that you're going to input into your normal inverse calculation is always going to be the area that's to the left of your x value, the less than area. So keep that in mind. Be smart as you're picking your inputs, and shoot me an email if you have any questions. And that's all.